Hello everyone, this is Sithara from Dept. of Chemistry, Syed College. Hope you are all doing good. So let's start our seminar on colloids. The topics that I am going to discuss are structure and stability of colloids, preparation of colloids, and Helmholtz electrical double layer and zeta potential. So let us start with the first topic, that is the structure and stability of colloids. Okay, the structure of colloids. Two phases are involved in a colloidal system: dispersed phase and the dispersion medium. The dispersed phase consists of colloidal particles having diameter 1 nanometer to 1000 nanometer, and the dispersion medium consists of the solvent or medium in which the colloidal particles are dispersed. Okay, so we already know what a colloid is. So colloidal solution അഥവാ ഒരു colloidal system എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is a solution which consists of particles having a size ranging from 1 nanometer to 1000 nanometer. So while describing the structure of a colloidal system, you have to emphasize on two phases, that is the dispersed phase and the dispersion medium. It is very easy to compare these two phases with the normal phases associated with a solution. You know that while you are considering a solution, there are two components, right? There are two components in a solution. Okay, so there is a solvent, as well as solute, which is the dissolved particle in the solvent, right? So these are the two components present in a solution. And similarly, in a colloidal solution or in a colloidal system, the dispersed phase is acting as solute, substance which is dissolved in the medium, and the dispersion medium is the solvent. So this is how easily we understand. Here we have an example in which water is dispersed in oil, which is water in oil emulsion. Okay, so next is the stability of colloids. See, there are two types of colloids. One is lyophobic colloid and the other one is lyophilic colloid. The classification of colloid is not the topic on my part, but still I'll give you an idea about what a lyophobic colloid is and what a lyophilic colloid is. So lyophobic colloids are those colloids in which there is no much attractive force between the dispersed phase and the dispersion medium. But in lyophilic colloid, there is a strong attraction between the dispersed phase and the dispersion medium. So let's move on to the stability of these two types of colloids. The stability of lyophobic colloids is due to the presence of electric charge on them. The aggregation of colloidal particles is prevented by the repulsions created by the electric charges of the same sign, thereby stabilizing the colloid. So, as I have already told you, there is no much attractive force between the dispersed phase and dispersion medium when it comes to lyophobic colloids. So, the stability is only due to the electric charge. So, what happens is that a colloid is a system which consists of a charge, right? So, if you are considering a colloidal system which is having a lot of positive charged particles, if all the colloid particles are positively charged, then there is a basic thing that we learn from our lower levels itself, that is the like charges repel and unlike charges attract. So since these are all positive charges, they repel each other, and this repulsions prevents the formation of aggregation. അതായത് സിമിലർ ചാർജസ് ആണ് കൊളോയിഡൽ സൊല്യൂഷനിൽ ഉണ്ടാവുക. അതുകൊണ്ട് തന്നെ ഈ പറഞ്ഞ സിമിലർ ചാർജസ് പരസ്പരം റിപ്പൽ ചെയ്യും അല്ലേ. അവർ പെട്ടെന്ന് കൂടി ചേർന്ന് ഒരു അഗ്രിഗേറ്റ് ഫോം ചെയ്യൊന്നുമില്ല. ഈ റിപ്പൾസീവ് ഫോഴ്സ് അത് പ്രിവെൻറ്റ് ചെയ്യുന്നു. അതുകൊണ്ട് തന്നെ നമ്മളുടെ കൊളോയിഡൽ സൊല്യൂഷൻ സ്റ്റേബിളായിട്ട് നിൽക്കുന്നു. കൊളോയിഡൽ പാർട്ടിക്കിൾസിൻ്റെ സൈസിൽ തന്നെ മെയിൻറ്റെയിൻ ചെയ്യാൻ വേണ്ടിയിട്ട് ഈ ഇലക്ട്രിക് ചാർജ് റിപ്പൾഷൻസ് ആണ് ഹെൽപ്പ് ചെയ്യുന്നത് in the case of lyophobic colloids. Now, when it comes to lyophilic colloids, there are two factors which determines the stability of a lyophilic colloid. I have already told you that in lyophilic colloids there is a greater force of attraction between the dispersed phase and the dispersion medium. So the first factor that contributes to the stability of a lyophilic colloid is electric charge of the same sign. I have already explained how the repulsions are helping to stabilize the colloid. The second factor is solvation, that is the tendency to bind with the solvent molecules. The layer of molecules of the solvent forms an envelope around the colloidal particles which prevents the form of aggregation. That is, നമുക്കറിയാം കൊളോയിഡൽ പാർട്ടിക്കിൾസിന് ചുറ്റും ആരുണ്ടാവും, സോൾവെൻറ്റ് മോളിക്യൂൾസ് ഉണ്ടാവും. ബിക്കോസ് ലയോഫിലിക് കൊളോയിഡ്സിൽ ആസ് ദ നെയിം സജസ്റ്റ് ഇറ്റ് ഈസ് ഫിലിക്. ഫിലിക് എന്ന് പറഞ്ഞാൽ ലയോഫിലിക് എന്ന് പറഞ്ഞാൽ ഡിസ്പേഴ്സ്ഡ് ഫേസും ഡിസ്പേർഷൻ മീഡിയവും തമ്മിൽ ഒരു അട്രാക്ഷൻ ഉണ്ടെന്നാണ് ആ വേർഡിൻ്റെ മീനിങ് തന്നെ. സോ ആ അട്രാക്ഷൻ കാരണം സോൾവെൻറ്റ് മോളിക്യൂൾസ് നമ്മളുടെ ഈ പറഞ്ഞ സൊല്യൂട്ടിന് ചുറ്റിലും എന്തുണ്ടാവും, ഒരു എൻവലപ്പ് ഫോം ചെയ്യും. Okay, due to the formation of this envelope, it prevents the aggregation. അതുകൊണ്ട് തന്നെ ഈ കൊളോയിഡ് പാർട്ടിക്കിൾസ് ഒന്നും അഗ്രിഗേറ്റ് ചെയ്യില്ല, കൂടിച്ചേരില്ല, കൊളോയിഡ് സൈസിൽ തന്നെ മെയിൻറ്റെയിൻ ചെയ്യും. So this is how we explain the stability of lyophobic and lyophilic colloids. Hope you all understood. Thank you.